frozen continent of Antarctica, a place of intense beauty and extremely cold, often violent weather. But scientists and staff at the Dome C research station were able to take a brief break on March 18, 2022, to bask shirtless and in shorts in a heat wave, the most intense heat wave ever recorded anywhere on Earth. And this heat wave occurred on the ice sheet in East Antarctica.
The weather in the polar regions has these very large changes, especially compared to the tropics. We're measuring the heat wave by the difference in temperature from that location's sort of average weather. So the average daily mean temperature in Dome C in mid-March is about minus 55 degrees Celsius, which is extremely cold. During the heat wave, that daily mean climbed to about minus 15 Celsius. So we had an anomaly of about 39 degrees Celsius with respect to the average temperature on that day. This event just sticks out like a sore thumb. Like you don't need any fancy statistical analysis or you don't really need to be a scientist at all to look at that data set and see this, as this, remarkable event.
At the University of Washington, climate scientist Edward Blanchard Rigglesworth and his team analyzed the Antarctica heat wave for publication in geophysical research letters.
The main driver were these very strong northerly winds. These very strong northerly winds brought an Australian air mass, a column of air that had been sitting over Australia. It imported that into East Antarctica in just 4 days.
And importantly, as the air cools, as it moves into Antarctica, it's losing its moisture, it's raining out. As that moisture rains out from the air, it releases latent heat and it warms the air. And we found that that was a really important part of this event, that the energizing the air by releasing the precipitation caused essentially the warming of the atmosphere that led to this event.
The 2022 warming leading to such a large heat wave temperature anomaly in Antarctica was not simulated by global climate models.
The day-to-day weather variations in a climate model, they don't necessarily line up with the day-to-day weather variations in the real world. So the hypothesis is that the climate model didn't simulate a heat wave like this because it never simulated this kind of atmospheric pattern of the very strong northerly winds. We tested it by basically nudging the model to the observed winds. And in that case, it produced a heat wave that was about 32 or up to 32 degrees, an anomaly of 32 degrees, which isn't quite as strong as the 39 degrees we saw in the real world, but it's 7 degrees warmer than anything that the model ever simulates sort of on its own, right?
The Blanchard-Rigglesworth team also found that climate change increased the 2022 heat wave by 2 degrees centigrade, and forecasts that by the end of this century, similar heat waves may rise by 5 to 6 degrees centigrade. An unsettling projection when you calculate the amount of heat that swept into eastern Antarctica in March of 2022.
We do that calculation throughout the whole depth of the atmosphere. And what we find is that there's an enormous amount of energy moving in, probably about 5 times the strength of the sun at this time of year. It's about 1,500 watts per meter squared that's moving into this region. And that's enough to heat the column of the atmosphere 40 degrees Celsius over the course of probably about 3 days in this particular event.
Right off the bat, we sort of had this hunch that this was likely one of the largest heat waves ever recorded, if not the largest. The physics involved in that large scale of a temperature anomaly, I think, is what really drew me to it. What we've started to do is try and characterize the frequency, intensity, and duration of these heat waves. One of the really interesting findings of this study was that if you recreate an event like this, but in 2100, so under much warmer environments, these temperatures actually get near or above freezing. And so what we would actually see with a similar heat wave is melting in the interior of East Antarctica, which is sort of unprecedented in historical times. So I think that's both really interesting and has important implications for surface melt, sea level rise, and coastal ecosystems.